So, good afternoon everyone. First of all, thank you very much for attending this talk. My name is Antoine and I'm going to talk about our RCD implementation on OpenBSD today. So I've been part of the OpenBSD development team for the last 10 years or so. I'm known as Jacoutot, aka KJA for the lazy ones. And I'm a cloud and automation consultant for a French company called DDSI. Regarding OpenBSD, since I'm mostly a sysadmin / infrastructure system guy, I work on stuff that I need to put OpenBSD in the real world. Stuff like sysmerge, rc.d, rc control, also help maintaining our implementation of libtool and other stuff. I did quite a huge amount of work in ports. I ported the GNOME desktop and became a GNOME committer and member of the foundation. And I also handle the French FTP mirror and ports build cluster. So, subject of the day, RCD. RCD is the joint work of the three people, Robert Nagy, Ingo Schwartzy, and myself. The original design and code implementation was done by Robert and myself, and Ingo was our German seal of approval, making sure that that our shell foo wasn't too bad. So the stuff we're going to talk about today, a little bit of history about how the boot process works on OpenBSD, the alternative RCD implementation or init system that we looked at, or requirement, a little bit of usage of RCD, what's behind RCD, and if I have time I will talk about the RC control tool, which is a small helper on top of the RCD framework. So first of all, disclaimer. Yes, RCD is just a shell script, and a very small one for that matter. The interesting thing is not the actual code, but the actual journey that led us to it. So, first there is this problem that pretty much every OS fixed a couple generations ago. Right before implementing RCD, and the main reason why I actually wanted something like that is that at the time I was deploying OpenBSD infrastructure in several parts of the world, and in country where Unix knowledge was next to nil. So since I like my sleep and I like my Sunday morning, after getting regular tickets during the weekend because people changed configuration and were not able to reload whatever service, then I thought that it was maybe time to have something kind of consistent, because when you tell people that you need to run this command or that command according to the service that you want to restart, then they get crazy. So yeah,
I think what's even worse, kill minus hub works for many, right? But if some daemon does not specifically doesn't install the stick hub handler, the default action is quit.
Yeah, I know.
Awesome, right?
Yeah. That was actually a reason for one of the weekend tickets, is that my stuff doesn't work anymore.
Oh. Yeah.
So the 90s code, the RC back. Yep. The way OpenBSD has booted hasn't changed much since its first inception. To put it roughly, we have the bootloader that will run the kernel, which will run init. And init will run the etc rc script within the bin.sh shell. It's been dependable, predictive, sequential, no dependency. It worked pretty well, but it was, of course, very static. There are two important files in the previous and current RC system, rcconf and rcconf local. The first one is the system-wide default configuration. The second one are the overrides. So the way we start a daemon is just putting an underscore flags to something, or to know if we don't want the daemon to start. And to start a service, then we put yes or no. So the difference between daemon and service is that the daemon is your regular program that you want to run in the background, while the service is more like a facility, like I want to enable PF, or I want to enable multicast, or I want to enable file system quota checks, and things like that. So that's pretty much how things worked before and after RCD. Nothing changed basically in the way we did things. So Our requirement, first of all, the current paradigm cannot change. We have to preserve the existing behavior. So that means that we had to plug our RCD system on top of the existent. There was no way that we could come up with something that would transform anything, or there was no way that we would be able to actually commit it to OpenBSD. So of course it had to be small, simple, robust, and comprehensive, and of course easily debuggable. But since it's shell, it's usually pretty easy. So we looked at a few alternatives at the time. Yeah, well, SMF, LaunchD, well, I'm not talking about System D, it was still in its infancies at the time. Well, SMFs, LaunchD they actually have quite nice features, but they would like completely transform the way we did things. We didn't want to replace init, we didn't want to replace cron or whatever System D stuff does. OpenRC, which is the RC implementation in Gentoo Linux and Alpine. This one was actually pretty nice. The problem is that it handled everything, from mounting the file system, setting up TTY flags, etc. Our goal for RCD was really only to handle daemons, and that's it, nothing else. All the rest needed to be kept the way it was. That is very static. Then we have a quick look at run it and daemon tools, but they were just a bit weird and really too different from the way we used to do things. Slackware Linux RCD system was actually not that bad. It resembled quite what we were doing at the time, minus the RCD script. But the problem with it was actually too static. As soon as you want to add an RC script to your system, then you have to register it in rc.m, which is the equivalent of DCRC or thing like that. If you want to change the flags, you have to manually edit the RC script. So that was not really practical for us. So then came the obvious choice, the RCD or RCNG implementation from NetBSD and then FreeBSD. We actually wanted to start and to start based on that implementation, but after looking for a while, there were so many little things that were different that we ended up patching the stuff all over, and we decided that it would make no sense to actually use that, and we were better starting from scratch. There was also another reason, is that we didn't want to use RC order because we did not want to have service dependencies. We still wanted to have a static ordering of the daemon. I want to emphasize the fact that we did not fall into the not invited here syndrome. We really did look a lot about the other implementation before we started our own. So we wanted something very small and targeted to our requirements, obviously. Something close to the OS. We didn't want something that would make a supervision of services. Nothing like event-driven, socket-activated, nothing fancy like that. We really wanted to be traditional and not change anything. So again, no automatic startup ordering. One of the reasons we wanted to keep the system to be static is that usually, well, if you end up running 15 or 20 daemons on the system and you want them to automatically start at a particular time based on service dependency, it's usually bad design, at least in my opinion. When I run system production, they usually run like 3 or 4 services, and these are really easy to order manually. So the initial landing of RCD happened in 2010. It was composed of etc, rc.d, rc.suber, and of course the RCD script themselves. At the time, it was designed for ports only and not of the base system daemons. The reason for that is that we wanted to be able to actually work on it without breaking anything in base. Of course, base was the unity.
That's a nice way to say politics.
Yes. So we decided to start with stuff that we were already using manually. That is use kill, pkill, pgraph, etc. Which was the standard facility to signal daemons anyway. We didn't want to go with PID files because, well, it's always first a bit racy. Second, not all daemons actually are able to create PID files, which means that we would have to create a helper for that. So that complicated things and for no real benefit for us. We really wanted to target like 90–95% of whatever the user would run. We didn't want something that would handle everything. So nothing like stop daemon to control the daemon startup creation and stuff like that. And of course, since the whole RC system was already in shell, then we kept using it for better or worse. Right before RCD happened, the way that we used to start daemon from installed from external packages was to run them from rc.local. And we actually kept this way on the initial implementation for ports, because the only thing that we had to change in the base system was just the rc local script, which at the time was an empty script, if I remember correctly. So there was really no disruption to the existent, and we kept the traditional way of starting the daemon. So that's basically the only change in the base system that was done at the time. So for whatever you have in this RC script variable, if it's executable, then you start it. Little word about rc.server. So that's sourced by the RC script. It provides all the subroutine, and at the time it was 54 lines of code, shell code. 54 lines of code. I'm repeating myself because that's one of the reactions that we got after sending a patch. So yeah, that's kind of amusing for 50 lines of shell code. Fortunately, most of the answers were actually quite pleased to see people actually working on having an implementation, because actually a lot of us are running OpenBSD in the real world, and that was much needed. But yeah, and that's also the reason why the static requirements and everything were that specific, because we knew it would be hard to swallow for some people. One release later, we were allowed to handle base system daemons. So what happened in the process? Well, the thing is that the way that the base daemons were run at the time, they were directly run from etc-rc. So the processes were not started in isolation, which means that you could get an unwanted variable in your environment, and that may lead to unexpected or dangerous behavior. While our RCD implementation uses su-l, so that your environment is completely dry. So here we'll see the difference between these two commands. Basically what the first one does is this. So you start your Apache web server as a user using su. And oh my god, you get some GNOME variable in there, dbus, whatever, okay, way too much information, etc home, and then the xx authority, and what the fuck is that? When you want to have that in the environment of your daemons. So that was basically what allowed us to move RCD in base. Actually, people got really freaked out when we showed them that. So the way the startup sequence works with RCD is pretty much the same that it used to work without RCD. Basically, you start doing stuff, then you start RCD daemon, etc. So RCD start by, for example, adding swap, setting up the TTY flags, mounting the root partition. It will start the network, it will create the random seed, it will clean up some leftover spool file, etc. And this didn't change, it's still the same, it's still static, it's still command, run directly from etc-rc. And then after that we have start daemon, which is a very small function in the etc-rc script, which only job is to actually start the rcd script. So you feed it with the name of the script you want to run. It will check in rcconf and rcconf local if these set scripts are enabled, and if that's the case, it will start them. So for example, start daemon syslog, pflog, ntpd, etc. Then you go back to a regular command, like to enforce quota, to start RC secure level command, RC first time, RC local, etc. So basically RC.d is a very, very small subset of the startup sequence. Most of the code that is run in etc RC is for running like just regular helper commands. So RC.d today, rc.server is 219 lines of code. In the process, etc RC lost 150, so that's quite a big feature gain for 70 line of code. So how does it work? So we have 4 + 1 actions available. I said +1 because restart is really stop and start. So you have the start action, which will start the daemon with some particular flags, with a timeout variable, which I will explain later, which user the daemon will run as, and in which class it will run under. Then you have stop, which will basically send a sig term to the daemon, reload the daemon with a sig-up, and check the daemon is running by running pgrep. We'll see that all these actions are actually overridable. So if -up, that's something stupid, you can override that. All of this action needs to be run as a privileged user, except for the check one, although there are some circumstances where check may need to be run as a privileged user. I will show an example a bit later. So as I said, they're all fully configurable and overridable, so if the default provided by the rc.server framework doesn't fit the needs, then you can change them in the RC script directly. And all these actions are basically the main and only user interface, so we try to keep them as minimal as possible. So there is no one start or one force stop, whatever, or the other keywords that you usually have in other RCD implementation. That's how a minimum RCD look like. I say minimal, but it's actually typical. Most of the base system daemon in OpenBSD are actually just that. The only mandatory variable that you need is daemon, which is the path to the daemon that you want to run. And then you source rc.server, and then you run the particular command that you feed the RC script with. So start, stop, reload, etc. On top of that, we have 2 optional flags. -d, which is the debug mode, which is used to, well, it will describe all the action that it does and output the function that it calls, as well as display the standard out and standard error of the daemon. We have the force mode, -f, which is similar to onestart, which is used to start a daemon that is not enabled in rc.conf local. For a reason that I will explain right after, that's a no-op for package for RCD script installed by packages. So the way we enable daemon are by setting the daemon flags variable, but it only works for base system daemon. The reason is that the base system only has knowledge about the base daemon because they all are coded in the RTC script and they're all running with the start daemon function. etc RC has absolutely no knowledge of which external RCD script it needs to run. So for that we created a small variable called package script, which you can order, and that etc RC will run all the RCD scripts that are listed in that variable in the provided order, and at the stop action it will stop them in the reverse order. There's a few variables that we use to interact with daemons. First one is daemon class. Its value default to daemon. And that represents the BSD login class that the daemon will run under. So we use that to increase resource limits, for example, for a daemon, or to change the niceness of a daemon, or to inject environment variable, etc. We have the daemon flags, which is the traditional RC variable. So this one didn't change, it's still the same. It defaults to no or empty. The default comes from rc.conf. And they represent the flags that we will pass to the daemon, if any. daemon timeout, which default to 30 seconds. This one is used it represents the maximum time in seconds that RCD will wait until a daemon is considered started, stopped, or reloaded. There's some daemon like Squid or big databases which may require more than 30 seconds to stop. And the traditional behavior is that if that's the case, then there will be hard kill, which you may want not to happen. So in this case, we'll increase daemon timeout to the value that you need to. And at last, we have daemon user, which is basically the target user for the SU command, and which represent the user that your daemon will run under. So all these four variables are overridable by the RC script itself, then rc.conf and rc.conf local. The way that you override variable in rc.conf and rc.conf local is that you take the script name and you append the variable that you want to override. So for example, if you want to override the daemon flags that's provided by the netSNMPD script, then you would put netSNMPD underscore flags in rc.conf local. There is an exception to that. It's daemon class. This variable is actually a read-only variable. You cannot set it using rc.conf local. It will be automatically set to a class that matches the RCD script name, if it exists. If not, then it will match the daemon class. So that would be a typical rc.conf local example. So the first line means we want to start APM with the -A flags, which is auto performance mode, I think. Second one, we want to start hot plug D with no flags. And the third one doesn't mean that we will actually start sane-D. Because the reason is that sane-D is an external package script, it's not part of base. So, as I explained earlier, it will never be matched by a start daemon in etcrc, so it will never start. So you have to explicitly add it to the package script variable. There's a few special cases that we have to handle. There's a few application, a stack of application really, that comes with a full bunch of different daemons to be able to work. Sonda is an example. The Sonda is only 2 or 3 daemons, that's not so bad. But there's stuff like Zarafa, the groupware solution, where you have like 6 or 7 different daemons. And if you want to interact with that, it's really painful if you want to restart the whole stack to run like etcrc, Zarafa, blah blah, restart, and do that 7 times. So for that, we use meta RCD script, which are not really RCD script, it's just regular shell script, which only job is to actually run the RC script provided in the order provided and with the action provided. There is another special case. This one is very tricky. It's how to run multiple instances of the same daemon. Because the way we match daemon is by using pgrep, and pgrep, depending on the way that the daemon started, you may actually match several instances of it. So what works in, well, I'd say 75–80% of the case would be to just link the original RCD script to another name, and you will change your daemon flags to put it different flags so that it appears different in the process. So far, that's the only way to run multiple instances of the same daemon. There is some work in progress to actually make it better. It was not part of the original design. There was something that came to the requirement quite late. So we're not too sure how we'll be able to handle it perfectly yet, but we're working on it. So let's have a look at the internals of RCD, which is provided by rc.server. rc.server is the entry point to the framework. It contains all the internal function, the default variable, etc. And it can be overridden by the script itself. As I explained earlier, for example, P minus up, stuff like that. We'll see an example. The first interesting function is the rc start. So that's the first line is exactly how we will run a daemon. So we use rc exec, which is this variable. So that's basically the su line and argument. So su minus l. Then we feed the daemon class, then -h. The daemon user we're running onto, and then the daemon and daemon flags. We have a small variable called rcbg that we use in case a daemon cannot go into the background by itself. So we append the % for that. And for example, this is how sshd is actually started. Then we have rc stop, which is just basically a pkill minus xf on the pexp. What is the PXP? The PXP represent the process line in the process list. That's basically the daemon you want to match. So it's constructed from the path to the daemon, so the daemon variable, and the daemon flags if you have any daemon flags. And that's this line that you may want to modify from time to time in case the default like that don't correspond. For example, daemon running set proc title will completely change the way they appear in the process list. So in this case, this will never match. So you can change that in the rc.d script. Then we have rc reload, which will run the pkill minus hub on the process list. And rc check, which is just basically a pgrep, will return 0 if the daemon is running. We have a couple of optional functions. rc pre. rc pre will be run by the start action right before actually starting a daemon. So it's pretty handy if you have pre-launch time requirements like creating directory to store socket with proper permissions or stuff like that. We use it actually with also stuff like cups that replace some base system utilities. So we first move away the base system utilities using rc pre. And we have rc post, which is the exact opposite. That will be run by stop when daemon process has been killed. So it's usually nice to do some cleaning. In the case of cups, for example, to put back the base system LP commands. Yeah. A little word about the unsupported actions. Kill minus up would be one. Some daemon do not support an action. If there's some daemon that don't support kill minus up, for example, that will indeed kill the daemon if you do that. So in this case, you override the function with a variable of the same name set to no. And if you try to do this action, then the rcd framework will yell at you. Yeah. There's also a small variable called user check. As I mentioned earlier, the check action can be run as an unprivileged user, but from time to time you need to have privileged access. Like Samba, for example, to check whether Samba is running. I think the rc.d script uses smb control ping, something like that, which require privilege. So in this case, you add the rc user check equals no in the rc script, so that if you try to check if the daemon is running as a regular user, then rcd will yell at you again. And then we have the main function, which is the rc command, which is the last function that the rc.d script will run. The arguments are, of course, the same as the one that you pass to the rc.d script. So it's one of the 5 arguments, start, stop, etc. So the argument as start. So what does the start action exactly do? First, it will check that the daemon is enabled, which is basically looking at rcconf and rcconf local. Check if it's not already running, which means running rc check. Then we'll run rc pre, rc start. And then it will store the PXP variable under the var1 rcd directory. The reason for that is that since we're doing real-time process matching, if I start a daemon with flag dash foobar and I want to change this flag, then I will edit rc.conf to bar foo. And if I want to restart my daemon, then the rc.d framework will try to match the new stuff that I put in rc.conf instead of the stuff that's actually running. So what rc.d does is just first it will have a look under this directory to see if there is a matching entry for the daemon that we want to restart. And if that's the case, then it will use that as a PXP instead of the one that is constructed from rc.conf. And then at the end, we wait up daemon time of seconds before stop. The stop argument will check that the daemon is running, so that's rc check. Then it will run rc stop, and then it will wait up to daemon time and seconds before hard terminating the process, and then run rc post. And rc restart is really just etc rc.d daemon stop, and if it works, then rc.d daemon start. And the reload command, we just check that the daemon is running with rc check and then run rc reload. The same with rc check, it's just a matter of running check. So, that was actually quite an improvement for us. We could finally use service handling in monitoring tools. Like, for example, if I monitor this or that process, I could actually instruct the monitoring tool to start it if it was suddenly dead, which was next to impossible before because we didn't know the flags. But there was still one thing that was missing, especially at the time. The infrastructure we were deploying required a lot of automation. As I mentioned, the reason is that the Unix knowledge of the people there were next to non-existent, so the infrastructure had to basically live by itself without too many human intervention. So we used Puppet at the time, and the problem is that there was no way to actually instruct this Puppet to say, well, enable the service or disable the service or enable the service with this flag or that flag. Basically, we needed some kind of rc.conf local editor. So that's what we did. So rc.conf is, well, you can see it as a merge of the service checkconfig and the sysconfig editor from, if you think about Red Hat land. It is an alternative. You don't have to use it if you don't want to. That is, you can use still use your favorite editor, VI or whatever, to manually edit rc.conf local, or you can use exclusively rc control, or you can use both. It's up to you. It's not one or the other. So another reason why we created it is this. That was also something that was really confusing to our users. I mentioned earlier the difference between service and daemons. So someone wanted to start SSH, so what do? Do I just put SSHD equals yes or whatever? No, you have to put SSHD underscore flags equal yes. Oh, perfect, so then for PF, it's PF underscore flags. Oh, no, not PF, PF is different. It's a facility, multicast as well. It doesn't work like that. You have to put yes or no. Well, that's okay. So RC control for that abstract completely this issue. You basically say RC control enable PF, RC control enable SSH, and it will do whatever it needs to do. So we're provided with a unified interface, which abstract all the weirdness behind rc.d, which completely abstract the daemon versus service thing, abstract as well the regular rc.d script and the meta rc.d script. Because, for example, if you input in your rc.conf local samba underscore flags equals something, then that will never work like we imagine, because samba is just a meta script. It's not a real rc.d script. So, and eventually we added rc control support in Puppet, Ansible, and Salt. To give you an example, that's the diff that was done for Puppet. So there was quite a huge amount of lines removed, which is nice, because at the time, Puppet was manually editing rc.conf flow code using Ruby code, while Salt and Ansible were doing the same using Python. So we really needed something that was in base and could handle all of that. One thing that came to our consideration when we developed RC control is that RC control needed to source rc.subr to have the actual configuration and default variable. They needed to source the rcd script and rc.conf local to get the configuration of the actual daemon he wanted to manage. And then we would source rc.subr again. I mean, it was completely crazy. And it suddenly looked very fragile. So what we did is that we created an rc parse conf function in the rcd framework, because eventually rc.conf and rc.conf local are supposed to be configuration file. They're not supposed to be a shell script, right? So there was no point in sourcing them. So we created this parse function to stop injecting shellcode in dangerous place, because at the time users were actually abusing rc.conf local to inject shellcode. So like a few users not really happy, but it was way safer this way. So the way RC control works, I guess it's pretty easy. You have get, def, and set, so you can get a particular variable for a service, you can get the flags, you can get the timeouts, you can get the user, etc. Get def is the same, but for the default. Set is when you want to set a particular variable. And then you can, of course, interact with the daemon the same way you would with the RCD script. So you can use RC control start full bar and pass the debug and force mode as well. You can disable, enable, and order. Order is only used for package script. It will reorder the package script variable the way you want it, so you can order do your service startup. And we have a RC control list, which takes several arguments. So if you want to know which service are enabled, which services are stopped, or actually which service are in faulty mode. Faulty mode means that it will list all the services that are supposed to run but that are not running. Don't consider it a monitoring tool or anything, but it's now run in the daily periodic script. And so it will tell you every day if you have a daemon that got killed for whatever reason and why it's supposed to run.
So can I use the order subcommand to the system daemons?
No.
Ports only?
Yeah, ports only. The reason is that the order of the base system daemons is statically set in etc.rc. We have the start daemon function that will start them in a very precise order.
There are some more dependencies. For example, NTP is run very early before a lot of the rest of the system is started, because you don't want to set the time hard late, right? And that's more RCD stuff, and this is just not expressible.
Yeah, there's NTPD, there's I think there's the auto mounter stuff as well. So it's very fishy.
But maybe, who knows, in the future, maybe we can find a way.
Maybe it's actually one of the big drawback of RCD on OpenBSD is that it's hard to actually inject stuff early in the boot process or at very particular moment. There are several ways to do it. You can use etc hostname.if, which is one of your network configuration card. You can pass command in that. Traditionally, you would pass root command to add routing entries, but you can also abuse it to run something else. It's not really pretty, but it's one way to do it. You also have rc.secure level, which is run by etc.rc pretty early in the boot process, but after the network has started, which are traditionally action that you want to run before setting the secure level, but you can put whatever you want. It's a shell script. Then there is RC local, which come near the end. And there's there's also RC first time. That this one's actually pretty handy if for installation or upgrade. With action that you will only run once. So typically like a provisioning action when you start the machine for the first time, and then the script will be removed by the RC system as soon as it's finished running. So that's actually how we install firmware, Wi-Fi firmware automatically on top. To wrap it up, RCD is not a replacement for the traditional BSD init. We're still working exactly the same way as we used to work. We're still very static. It's not a process control framework, but that's by design, and it's not a service supervisor. It was a design from the start that not only we didn't want to change the way we were doing things, but also there's stuff like supervision of service that we think it might be better handled by external tools. So basically it's a compromise between feature, ease of use, and simplicity. So obviously it may not be suitable for all possible users. I already mentioned the drawback. Multiple instances of daemon is a very big one. And of course early startup of specific daemons. So on and on, it's just boringly simple but robust. We preserve the original paradigm, and we've built our stuff on decades-old component, pkill, pgrep, etc. That small tool that do one thing and do it well. We were able to provide a consistent and unified interface with RC control, and a funny thing is that we can actually be easily integrated into other operating systems. We actually created a small Linux distribution based on Core Linux and BusyBox that used the RCD, OpenBSD RCD framework. The only thing we had to modify a little bit was the rcconf parse function because we're using KSH, one shell construct, and on Linux you have bash, so it's a little bit different, but that's pretty much the only thing we have to modify. We're currently working on integrating our domain support so that you can start a particular daemon using an RC script in a particular routing table. I believe this will be committed within the next few weeks. Yeah.
This is awesome. This solves problems for me.
See? We solve great problems. And yeah, and I guess that's it. Questions?
What do you think of the speed of rcctl, speed of execution?
Define speed. Which action?
Well, for instance, to get the service status. Is it acceptable from the Puppet and others point of view?
Yeah.
Yeah?
Yeah.
We have run into performance problems with rcctl.
Well, I'm over here.
Sorry?
I'm over here. I am over here. I'm listening to you.
Right. Sorry. We ran into few performance problems with rcctl and had to move some of the functionality for other language.
What exactly were you doing?
I think at least the get status of all services.
Oh, of all services.
Yeah.
Yeah, this one's slow. That's true. Yeah, it's slow. The problem is that to get the status, you need to of all the services, you have to check all the RC script to see if they're running.
Right.
And that means that you have to source the RC script, you have to parse rcconf and rcconf local. So it's perfectly acceptable when you do that service by service. It's instant. But of course, when you have 100 or so RCD script, it takes some time.
Any plans to change the situation, address somehow?
Honestly, it's somewhere on my to-do list, but I have absolutely no idea how to actually fix that.
Rewrite rcctl and C.
Yeah, good luck with that.
Not to spawn.
Good luck with that. With all the parsing and stuff, yeah. Well.
Perl.
Yeah, Perl could be doable, but I mean, in the end, we'll still be running into. It will be faster, but not that much faster, I guess. I still need to do some.
Well, at least you wouldn't be forking so many things.
No, that's true. Yeah, there's a lot of subshell forking.
I doubt benötigt ist the forking. Fork is that expensive.
Well, not fork itself. Forking and running shell with sources strings, post peak ref, so on and so forth.
Yeah. No, we get to. I'm perfectly aware that. Okay. It's just I have honestly no bright idea how to fix it.
You can maybe fix that by first looking at everything you got down in var, run, RCD.
Yeah, that's what I.
And consider those.
Yes, but that's what I did first. But then I reverted that because it's too fragile.
Yeah.
I don't want to trust what's in there. That's why actually I always fall back into the on-time parsing of the process list in case there is some fuck up later. Any other questions?
Please show the rc control command line page, your presentation.
You mean the usage?
Yeah. What is action?
Action represents the action that you can give to an RC script. So start, reload, etc. Yeah, actually, it wasn't planned to do that, but it came out to be so easy. It's just run the RC script. So.
Can I edit the rc.conf.local file using the set?
Yes. Yeah. Yeah. And since it's an abstraction, if for example on OpenBSD, if you run rc control enable SSH-D, then nothing will happen in rc.conf local, because by default it's enabled in rc.conf. So you only get what's non-default.
The rcctl fault is run daily. Is that going to be rcctl ls fault?
Oh yeah, sorry, that's ls. Well, thank you very much.